This is the last video of Chapter 8. We are looking at the structure of lakes and how we divided this one into 4 zones based on the depth and distance from shore. So littoral zone, like the intertidal zone of ocean. Near shore, where rooted plants grow, high biodiversity. And then you also see turtles, frogs, crayfish, and some other fish. The next one is limnetic zone, like the euphotic zone of ocean. So those are open, sunlight area away from shore. This is the main photosynthetic zone. This part also you can see some fish. So again, look at this diagram intensely, kind of take a picture in your mind. So when they mention littoral zone, when they mention limnetic zone, you know where they are, okay? So if you look at the profoundal zone, this one is the middle layer. So like the basal zone of ocean, deep water, too dark for photosynthesis. And then if there's no photosynthesis, you have a low oxygen level, you have some fish living there. And then the bottom part you call benthic zone, like the abyssal zone of ocean. You have decomposers, you have detritus feeders, some fish. And then this area is nourished primarily by dead matter. After decomposed, they become nutrient for other things. So again, spend some time to look at this slide to know the ecological services and economic services of freshwater. So many of them, they are overlap with the saltwater ecological services and economic services. And then if we look at their nutrient level, we also can divide the aquatic environment in different ways. So one is called oligotrophic. Remember, trophic means nutrient. And then oligo means few, very little. So those are low level of nutrients. If there's less nutrients, you have a lower net primary productivity. And then the water is pretty clean. There's nothing there. And then you have eutrophic lakes. So this one is U means real, true, and then trophic means nutrient. You have a lot of nutrition there. So these are high levels of nutrients, and then they have high net primary productivity. So because of that, so the water is kind of muddy, and then with high turbidity. And then you also have cultural eutrophication. This one is man-made eutrophic lake. So this part is, they get a nutrient like phosphorus and nitrogen from man-made fertilizers called eutrophication. So this diagram is oligotrophic because you see the water is so clean. On the other hand, this one is eutrophic. I don't know, this one is man-made or nature-made. Pretty much look like a human activity caused. So this one, eutrophication, too much growth of algae. And then we also can look at the water course, where the fresh water, we get it, and then how they flow. So we divide the water into different ways. So you have 3 ways. One is the mountain, and then one is the transition, and then one will be the flood zone. So if you have the mountain, where is the source of water? So you have a snow melt, you have ice melt, right? So those water sources, when they melt, they are shallow, they are cold, they are clear, and then they run fast. And then since they are cold, they can hold more oxygen in it. So look at this diagram. So this one is the source zone. So here you store a lot of fresh water. And then this part is transition. So you have water passing through this area, and eventually this is the floodplain zone. So this part has a lot of nutrient, but also if you have a flood season, this area could be flooded. And then eventually the water get into the ocean. Okay. And then one structure one you see is called a delta. Those are the small island made by the deposited sediment. We're going to talk a little bit of that. So the transition zone you see in the middle part, they are wider, they are deeper, they are warmer streams. Because if they are shallow, they are warmed up by the environment, right? So they are more turbid. They pick up the sediment. And then they have less dissolved oxygen. When you get the flood plain zone, the water even wider, you could have deeper rivers, and then broad, you can have flat valleys. Depends on the local geological structure. Remember, we mentioned the coastal delta. So those are the small landform that forms from deep deposition of sediment carried by a river. And then you also can have mangrove, you can have coastal wetlands. They all provide natural protection against the storm because they act like a barrier. And then we have man-made dams and levees reduce the sediments in the delta. So for long run, the delta would have erosion and without supply from water because we dammed them, right? And then we also have a sea level rise and then flood coastal area. So those are all related with the human activity. So this one is just to show you, remember, a lot of human activity development is on the coastal area. So if we have 1 meter, about 3 foot of sea level rising, that's how much would be flooded, which is a big loss of economical impact. And then wetlands, you not only see near the seashore, you also can have an inland wetland. So those are the lands, they are land, but many times or a long period of time of the year, they are covered by water. So those could be marshes, swamps, prairie, potholes, or floodplains, and even Arctic tundra is a part of the inland wetland. So those areas often would be damaged by human for other activity, but actually they are very important. So they provide ecosystem and economic service, such as filter and degrade toxic waste. They reduce flooding and erosion. They help to replenish streams and recharge groundwater. They provide biodiversity. They provide us with food and timber. They provide recreational areas. So you can look at this one. The left one is the Everglades in Florida. And then the other one is the Cypress Swamp in South Carolina. Those are all belong to inland wetland. So here is the last section. We're looking at how human activity impact the economical and ecological service provided by freshwater. Pretty similar to what we have seen in 8.3, our activity damaging the marine ecosystem. Okay. So we build a lot of dams and canals to use water. So they restrict the flows of river. So that means we change their course, change or damage the habitat. So 40% of the world's largest rivers has dams and canals. And then we also build flood control systems. And then in turn, they change the aquatic habitats, change the wetlands. And then near water, we always have cities, farms. They produce pollution and then they get into the water. One more thing is many wetlands have been drained for human purposes. So people use those land to grow crops. So the wetland is not able to store water for us. The wetlands is not able to provide biodiversity or prevent erosion for us because we use 80%, convert them to farmland. So summarize human activity. So 1, building dams and canals, changing flow and destroy habitats. 2, building flood control structures such as levees, disconnecting rivers, destroy habitats and wetlands. 3, adding pollutants and excess nutrients, causing eutrophication and habitats degradation. And then number 4, many inland wetlands have been altered into other uses, such as farmland, building roads, destroying habitats, and increase runoff. So those are towards the end. We summarize the whole chapter. So the 3 big ideas is number 1, water dominates the planet. So seawater and freshwater aquatic life zones cover almost 3/4 of the Earth's surface. Second one is the Earth's aquatic systems provide important ecosystem and economic services. And then number 3, human activities threaten biodiversity and disrupt ecological and economic services provided by aquatic system. And then if we tie up all this together using coral reefs, okay, so coral reefs thrive on solar energy, and then they participate in nutrient cycling, and then they are able to sustain aquatic biodiversity. So basically, why the coral reefs are successful, because they obey the 3 sustainability laws of nature, using solar energy, and then rely on nutrient cycling, and then they maintain their biodiversity. So in nature, everything is connected. How can we reduce harm to coral reefs? There's many activities we can do to reduce or even recover the damage we have made in the ecosystem. Okay, everyone, thank you for watching. Hope you do well on Chapter 8, Quiz and Test. Thank you.